Okay, we are going to learn about the vertical motion of an object and what are the locations of the objects at different points and different time intervals and all that we are going to see in this problem. Okay, the given scenario is like this. The formula for vertical motion of an object is h of t is equal to 0.5 times at square plus v times t, and that is equal to s, where the gravitational constant a, this a, is equal to negative 32 feet per second square. See, the acceleration is measured in units per second square. Here it is feet per second square. And the velocity v is the initial velocity, that is the starting velocity, and it is measured in feet per second, units per second there, and s is the initial height. So this h of t is equal to s, the height at the starting point is s, it is of course. Now the time t is measured in seconds and height is h is measured in feet, and it is given the initial velocity of the object is 120 feet per second. So using this information, what function describes the height h of the object in t seconds into the launch? Okay, so the given values are what? We have this a is equal to negative 32 feet per second square and v is 120. Let us substitute those values in this function h of t. Okay, now h of t is equal to 0.5 times a is equal to how much? Negative 32. We will write down negative 32 times t square. Time is t square plus v times t, and v is how much? 120 is the initial velocity times t. I'll just leave it as t. Okay, now simplify to give h of t is equal to, what is 0.5 times negative 32? 0.5 is nothing but 1/2. 1/2 of 32 is 16. So with the negative sign, positive times negative is negative. Negative 16 t square plus 120 t. 120 t is the function that describes the height. So for height, the height of the function at t is equal to 2. If you want to find for t equal to 2, just substitute t is equal to 2. Whether for different values of the time, you can find the height. Okay, and that multiplication, let me just show you. It is 0.5 quit 0.5 times negative 32. That's 16, right? Okay. Now that is the equation function of this object you got. Now using technology, sketch a graph of the position of the object as a function of time into launch and give a verbal description of the graph. Include a reasonable domain and range. Alright. Now let us draw the graph. Before that, let us reset the calculator. How do you do that? Hit second and this plus, go to 7 and then 1 and then 2 for reset. Everything is cleared. Now go to y. Nothing is in y. Enter the values. Negative 16 t square. So these are all the variables like x, t, theta, and it is same thing. I can write down negative 16 x square plus 120 x Alright, now hit the graph and see what happens. Nothing, we don't see a clear graph, so we have to adjust the window. To adjust the window, I think the best way is go to the table and see. How do you go to the table? I'll hit the second and graph again. That leads you to the table. In this, you are seeing that when x value is 0, y is 0, then 104, for 1 it became 104, etc. Now what's happening to the y values? It is increasing, 176, 216, 224. Now it's going down. Okay, so what is the highest value I'm seeing? Around 224 for y, and x is ending at 7. See, when you go to 8, the y value became negative. We don't have the negative height, so we don't have to worry about up to this number. Therefore, x values I can start from 0 and go all the way up to 8. Of course, 8 is not included. And the maximum height here I'm seeing 224. So I'll take somewhere up to 240 like that y to get a better window. So now go to the second here, second button on the top which says window. I'll enter my x value 0, the minimum, the maximum 8 I'm taking, and this is scale. It's better to go by 0.25 or 0.5, that is half units also will give. I'll show you what difference it makes. And then y minimum is 0, y max will go around 240. Now, and the scale, I'll take 10, hit the graph. Right, this is the graph. And those little dots here on the x-axis, those are for every 0.5s you are having. Suppose if you take it, 0.25, now if you make it as 0.5 halves and hit the graph, your graph will be this way. Like dots are just spread out. Alright, so this is the neat graph you got. This graph is the graph. Okay, it is the graph of that function h of t is equal to negative 16t square plus 120t. Now we are also asked to describe. So what's happening to this graph? So for t value at the beginning it started at 0 and went all the way up to around 200 and what's the max value we are seeing here with reference to this table? It was around 224, and in the end it even reached to 0. After 7 seconds it is going down. Okay, so our reasonable domain will be the values starting from 0 and went all the way up to 8. So my x values I can write like this. The domain, what is the domain? Your x value was more than or equal to 0. So we are going this way. That is 0 is less than or equal to x, or x is greater than or equal to 0. Because you are starting from this 0 here and moving this side onto your right. And that side you went all the way up to 8. So I'll write less than 8. Why I'm taking less than 8? And it's an approximation just. Because if it is 8, if the value of x equal to 8, you're getting a negative value for height. We have to stop at 0. That's why I just wrote less than 8. Now the range in this, the maximum value you're seeing 224. So now I can set the table for the decimal values of x also. So here I'll just press plus, right, and then I'll hit 0.25. That's for every quarter we are seeing. Then hit enter. You will have, see, after 2 it is 2.25 you got. So starting from 0 you see 0 and went up to 0.25, then 0.5, like that. It is, we are finding the values of this y for even half and quarter values of x. So as you go down, I can see that instead of 224, is there any increase? Yeah, I'm seeing 225 is the maximum value. I'm seeing it over here. Therefore, I can say that the range, the y values, on the y side is the range, x values are the domain. So range is starting from 0 and it's going all the way up to 225. When we actually calculate, it can be even greater. So it is just an approximation right now, and later on we'll confirm either this is the highest value or something else. Okay, now the range is y value, y is reaching 0 or more than 0, so y is in between this and less than or equal to 225, right? So that is the value of y we are seeing here, that is the range. Now the next question, how high is the object t is 2 seconds into launch, and when is it at this height again? It is very easy now. So you want to find the value of h for t is equal to 2, and whatever height you see here, are you going to find it again? That's the thing. So let us go to t is equal to 2, that is the time is 2 seconds. In 2 seconds, what is the height? 176 feet, right? So h of 2, that's the better way of representing, because t is equal to 2, t is equal to 2, so h of 2 is equal to, what was the height? 176. I'll write 176 feet. Now, when is it at this height again? So scroll down. We have to be on this y side. Then 224, it's 221, it's going down, 216. Where is it? 176, yeah. At 5.5, I'm seeing 176 again, right? So at t is equal to 5.5, the height is again, height at 5.5 is 176. So we are observing that these values are repeated. See, after this middle value over there, at 225, see both sides 224, then 221, 221, above it will be 216 and 216 there. So like that, the values of this graph, the y values are repeated for the different values of x. Okay, we are going to see much more of this in the next items. Okay, now what is the average rate of change of this function between 4 and 6 seconds? Explain this rate of change in the context of this problem. Okay, so what is the average rate of change? What is the formula for rate of change? It is delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. So at 4 and 6 seconds, we are looking for the values of y for x equal to 4 and x is equal to 6. These are the x values. Find the y values from this graph. I'll hit second and the graph to get the table. Okay, then I'll see, go to 4. For 4 it is 224, and 6, 4 is 224, and for 6 it is 144. 224 and 144. Right, 224 and 144. Okay. Right. Let us substitute the values here. Y2 is how much? 144 minus x2, 224. Divide. Y2 is a 6. X2 is 6 and x1 is 4. So what is 144 minus 224? Okay, is it 80 with the negative sign? Let me see, second and mode. I'm out of that. 144 minus 224 gives you negative 80, and 6 minus 4 is 2. Okay, negative 80, and 6 minus 4 is 2. So average rate of change of this function is a negative 40. And what is the units? Feet per second. And what do you mean by this? When you follow the graph over here in that time period, from 4 to 6 seconds, means you are somewhere here, from 4 to 6 seconds you are coming down. The height is reducing at different intervals of as you are proceeding after 4, 5, and 6 seconds. The height of the object is going down at this rate, at 40 feet per second. That's the meaning of it. Now approximate the speed of the object 3 seconds into the flight, and how you made this approximation. So what is the approximate speed? We are looking for the speed. Like it is an instantaneous velocity, but instead of going to that formula, you can directly approximate it. You just have to approximate. So what do you do is, I'll go to the table again. For 3 seconds you are looking at. So either before 3 seconds or after 3 seconds, and at 3 seconds we'll take two values. Like at 3 it is 216, at 275 it is 209. So let us take those values over here. Okay. How much it is? 216 minus 209. Y2 minus Y1 I'm writing. Y2 minus Y1, that is 216 minus 209. 216 minus, minus is over there, 209. Alright, denominator is 3 minus 2.75. 3 minus 2.75, that's the closest here. So 216 minus 209 is how much? It is 7. 7 divide 3 minus 2.75 is 0.25. Okay. So 7 divided 0.25 is 4 times 7, that is 28. I think 28 feet per second. Okay. Let us look at it with calculator also, just in case. I have to get a fraction. I'll show you that part also. In order to get a fraction, I just have to hit alpha and go to y, There you see n over d, that is numerator divided denominator, and on the top you have 216 on the numerator, denominator, okay, numerator is 216 minus 209 divide in the denominator 3 minus 2.75. Come out of the fraction, hit enter, that's 28. Okay, 28 you got. You can verify, or you can just use your calculator to find these values. Now the last one, determine the time at which the object hits the ground. So at what time the value of y, this becomes a 0 that you have to do, and here this is also approximation. Go to the table and let us see, it is going down 176, 144, 81. So at 7.5 you are seeing a 0 here, right? The value of y is equal to 0 and x is equal to 7.5, and you can verify this by hitting the second and this trace, that is the value. Alright, that's one. We'll show you the other thing also. At x equal to how much? 7.5, that gives you 0, y equal to 0. Likewise, we have different methods of finding the values or of this function, or the graph of the function, etc. And here it is, one of them we already did. So that is to determine the time at which the object hits the ground. So the time t is equal to how much? 7.5. At 7.5 seconds we are seeing that the graph or that object is hitting the ground. So if we want, we can go back and change this 8. Instead of less than 8, you can just say it is less than or equal to 7.5, right? That is the domain, the final domain also we got. So this is how you can find the various values for the height in the different locations at different times for the given object. Okay, thank you.